Hello all, Sri Sai Tech Edu YouTube channel, Read Lead Success. I am dealing with the subject Network Analysis and Control Systems. Already module 1 videos have been uploaded. If you have missed that to watch, please do watch. Now I am starting with the videos of module 2. It also contains 2 chapters, that is 2-port networks and Laplace transform. Under 2-port networks, there are 5 topics we are going to learn. 6 topics we are going to learn. That is 1-port network, admittance parameters, some equivalent networks, impedance parameters, transmission parameters and hybrid parameters. Now in this video, we will learn 1-port network and the theory of it and the problems of it. 1-port network. What is 1-port network? A pair of terminals at which a signal may enter or leave a network is called a port, and a network having only one such pair of terminals is called a 1-port network. What port means is like a signal that is entering or leaving a network is called a port. See, here it is entering, so it is input port. If it is leaving, output port means, and the network which has such pair of terminals, one such pair of terminals is called 1-port network. Like it has only one such pair of terminals, that is one input port and output port. Such one pair of terminals is called a 1-port network, or simply a 1-port networks you can see here. No connections may be made to any other nodes internal to one port, and it is therefore evident that IA must be equal IB in that one port. Here, as there is only one node, no connections may be made to any other nodes. There is only one port, that is one input port and an output port. The pair of this is 1-port network. So IA will be equals to IB in this 1-port network. Then when more than one pair of terminals is present, then a network is known as multi-port network. If there are many terminals present, then it is multi-port. For such, if it is more than one port, if it is 2 ports, that if you see in this diagram, see, IA it is there, IB it is there, IA, IB, IC, ID. Here, these two will be the input ports and these two will be the output ports. Such pair of 2 terminals, if there are 2 pairs of such terminals, so it is called 2-port network. And we can tell that IA will be equals to IB and IC will be equals to ID in 2-port network. The current in the 2 lead making up each port must be equal. Here also, it must be equal. IA equals to IB. Here, thus if we write a set of loop equations for a passive network, then it will be in the form of V1 is equals to Z11 I1, Z12 I2 plus Z13 I3. So on, so many equations. How many meshes are there? Those many equations we will write. So what we can write from this is the delta sets, that is Z11, Z12, Z13. That matrix can be written, that is seen here. Delta set can be written. After that, if you think that there is a 1-port network with one voltage source and the current I1 is passing through it, then what is the equation? Using Cramer's rule, I1 will be equals to what? We'll replace the first column, that is this first column, with the right side column, that is voltage V1 0 0 0. If you don't know the Cramer's rule, there is a YouTube short which I have uploaded. You can check that, or in the previous videos also I have explained in the videos in the module 1 Cramer's rule. You can just check that. From this you can write I1 is equals to what? V1 delta 1 by delta Z. How? So input impedance Z in, for this input impedance Z in is equals to what? V1 by I. So V by I is equals to R. You know that. So V by I is nothing but, if you replace this, if you send this I1 this side, then what you get? V1 by I1 is what? Delta Z by delta 1. Delta Z is what? The determinant of Z. The determinant of Z, and delta 1 is what? The delta 1 is the nothing but the cofactor of first. If you remove first column and the first row, then you will get the delta 1. If you see the sums, you will get the clarity. You just understand the formula, so you can use. I'll explain the sums in the next slide, so you'll understand. We may also select similar procedure using nodal equations yielding the input admittance. If you want Yin, then we need to use nodal equations. Than the here, if you want Zin, we use KVL mesh equations. But if you want Yin admittance, you know admittance is the inverse of Zin, that is impedance. So you need to use here nodal equations yielding the input impedance, that is delta Y by delta 1 1. Same formula is same, just it is the inverse. If you want the input impedance from this, first if you find delta Y by delta 1 1, if you inverse it, then you will get Yin, input admittance, where delta 1 1 now refers to the minor of delta Y. Here delta 1 1 refers to the, I am sorry, I have told it as delta 1 as cofactor. It is not cofactor. Delta 1 1 sorry, I am sorry, delta 1 1 I have told it as a cofactor, but it is not cofactor. It is delta 1 now refers to the minor of delta Y. Here delta 1 refers to the minor of delta Z. Okay, please do correct that. If I'm telling wrong, I'll just correct it then and then. So please listen the whole video. See, if delta 1 1 here is minor of delta Z, and here delta 1 1 is minor of delta Y. You will see now some sums. You will understand how these equations are used. Consider the following system of equations. They have given some system of equations, 3 set of equations. From this we need to write delta Z, and we need to find the delta Z and delta 1 1 and calculate I1. They told. We'll see. First you write in delta Z, that is -2, 4, 0. There is no I3 component, 0, 5, 1, -9, 2, -5, 4. Understood, right? After writing delta Z, what you will write? That is multiplied with what? I components. So that is not required. That is multiplied by I components. So -2, 4 we will written in the delta Z. After multiplying with delta Z, what you will do? You know how to calculate the determinant. For the determinant, if you don't know, I've already uploaded the video for defining the determinant in Calci. If you can do it manually, it is easy, or if you want to do Calci also, it is much more easy. You can use Calci. That YouTube shorts I've already uploaded in the video, in the YouTube shorts. You can check it. Here if you want to calculate manually, I'll explain. -2 into this 4 into 4 minus 9 is 45, minus 45, this -4 into then you will remove what? This column and this row, then 5 4s are 20, minus of minus plus -18. I hope you know how to find the determinant. In maths you will learn, and anyway it is 0, it will be 0. If you multiply anything with 0, you will get 0. No need to remove this 2 and find y, because it is anyway 0. Okay, after finding it, you will get as delta Z is equals to -70. Then delta 1 1 is what? The minor of delta Z. The minor of delta Z is delta 1 1. 1 1 indicates that first row, first column need to be taken. This first row and first column will be taken. Then 1 -9 -1 4, you will get as -41. That's it, delta 1 1. Then after that, what we want? I1. I1 is required. I1 is equals to what? In the previous slide we have already seen the formula as V1 delta 1 1 by delta Z. So 3 into 41 by 70. I1 is what? 1.757 amperes. I hope you understood now how the equation is used for calculating the sums. Second question, calculate the input impedance for the one port resistive network. They want input impedance, that is nothing but what? Delta Z by delta 1 1. First we need to write mesh equations for I1, I2, I3, I4 for all the 4 meshes. We'll write that. Apply KVL to mesh 1. KVL to mesh 1, we get V1 is equals to 10I1 minus 10I2. And KVL to mesh 2 will get -0 is equals to -10I1 plus 17I2 minus 2I3 minus 5I4. Then mesh 3 you will get as 0 is equals to 0I1 minus 2I2 plus 7I3 minus 1I4. Then for mesh 4, 0 is equals to 0I1 minus 5I2 minus I3 plus 26I4. By now you need to know how to write the mesh equations here. If you don't know how to calculate mesh equations or how to write KVL, then there is a separate video for mesh analysis in the module 1 playlist. of my YouTube channel. You just check mesh analysis how to do. Even though anyways I'm writing in a clear way itself to understand. If you're not even understanding after writing in the clear way of one by one step, then you can check once with the video what I've uploaded for the module 1. Then from this delta z need to be written. Here if you see I1, I2 components are 10 and minus 10. There is no I3, I4, 0, 0. Then minus 10, 17, minus 2, minus 5. Then in third equation 0, minus 2, 7 and minus 1. Then in fourth equation 0, minus 5, minus 1, 26. Like this you will write delta z. After writing delta z, what you will do? You need to find the determinant. How to find determinant? As it is here 4 cross 4. If it is 4 cross 4, it is tough even by the calci to find the determinant. Then what we need to do is, first 10, you remove this row and this column, you take this determinant plus, then what we will do? Then you remove this and this, that is nothing but minus of minus, you will multiply this, minus of minus, you will do, why? Because anyway whenever we are taking plus minus we take in determinants. You need to know these rules, okay? But then too I'm explaining once again in the video. Minus of minus plus 10 into 10 minus 2 minus 5 0 7 minus 1, except this you will write all the numbers. Then anyway the other two are 0 and 0, you can directly write them plus 0 into plus 0. Why? Because anyway you will get 0. After that, using calci, you can find 3 cross 3 determinant into 10 and this into 10. You will get what? Delta z is equal to 9680. 9680. For impedance, you know, impedance and resistance, it is ohms. Ohm power 4. Why it is written is, it is 4 cross 4 dimension. Here if you see, it is 4 cross 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 4 rows, 4 columns. So, ohm power 4. We will write. Why? Because it's 4 dimensions. Then eliminate first row and first column. So, we'll get what? Minor of delta z. Here it is 4 cross 4. What we will do? You will remove first column and first row. Then what you will get? You will get the minor of, that is first row, first column will be eliminated. So only we will write as delta 1 1. You will get the delta 1 1 as 2778 as the determinant. After that, input impedance Zin is equals to what? Delta Z, that is 9680 by delta 1 1, that is 2778. You will get as 3.485 ohms. Here delta cube, sorry, not delta cube, it is ohm power cube is why? Because 3 rows, 3 columns are present in this matrix or the determinant. Okay. Next question. Find the input impedance of the network shown in figure if it is formed into a one-port network by breaking it at terminals A and A dash, B and B dash. If you see here, we need to remove this terminal systems, and at A and A dash, what is the input impedance we need to find, and in the second B and B dash we need to find. We will see how. We will remove first this A and A dash and we'll write that as A and A dash. We want input impedance at this position, at this point, looking into these terminals. What we can see here is, if you see carefully, this is in the form of what? Star, or it is in the form of Y network. So what we can convert star to delta, if you convert, it will become easy. What is the formula? Easy formula. And for this also, for star to delta and delta to star also, I have uploaded a YouTube short video, easy technique to find star to delta and delta to star. You can check, or else there is full length video of star to delta, delta to star problems. You can find there how to solve the equation. Here now anyway I'll explain once again. Here if you see, this is delta form. This star to delta you need to see. When if it is star to delta, what we do? We first multiply the adjacent resistors, all like 3 into 6 plus 4 into 6 plus 6 into 3 and sum of those products by, if you want this R1, the opposite resistance you will consider, by 6. If you want R2, the opposite resistance to R2 is 4. So 4 will divide. The numerator will be same in all the cases. This is, you will get the R1, R2, R3 in the form of delta. After getting the delta, how the network looks is in this way. See, you will get R2 as 13.5, R3 as 18, R1 as 9 ohms, and this 2 ohms is common, 7 and 5 will be there itself. Then what we have here is, here 9, 18 and 7 are in parallel, 2 and 9 are in parallel. If you calculate them, you'll get 5.04 and 1.636. If you put those values inside this, then you will get what? 5.04 and 1.6363 ohms, then 13.5 ohms. If you see here, 1.636 and 5.04 are in series, you add them and they are in parallel in terms with 13.5. See, 1.636 plus 5.04 is 6.636, and this is in turn parallel with 13.5. If you calculate parallel equation and find the Zin, then you will get the Zin value 13.5 into 6.636 by 13.5 plus 6.6363. You will get as 4.449 ohms. This is the final input impedance across A and A dash terminals. Zin you got as 5 plus 4.449 ohms, that is 9.45 ohms as the input impedance across the terminals A and A dash. In the same way, we need to find for B and B dash. We need to find at B and B dash. We'll see that now. If you see here, accordingly at B and B dash, if you remove the upper portion, the network is in what? Delta connection. Right? How it is delta? If these resistors are like this and like this, if 3 and 4 are like this and this is delta only, no? I told you many times that in videos, if the connection is connected here also same, here also same. So you need to carefully see. So it looks like delta. You can convert into star. How you can convert? For converting, what we do? The easy form is R1 is what? You need to multiply the adjacent resistance 3 into 2, 6 by addition of all the resistances of the delta, that is 3 plus 4 plus 2, you will get as 9. 6 by 9, you will get the 0.67 ohms. In the same way, R2 and R3. For R2, that is 4 and 2 are in adjacent. Then for R3, 3 and 4 are in adjacent. Then after that, the network looks like this. R3 is 1.34 and R1 is 0.67 and R2 is 0.89. This 5 ohms, 7 ohms and 6 ohms will be there itself. Then what we have? Then this, if you see, they are in series. This, if you can see, they are in series. They are in series. You will get at 7.89 and 5.67 and 1.34 and 6. As you can see, in the between, in the center, whatever the B and B dash, they are in the open terminal. So 5.67 and 7.89 is parallel. If you combine those both, you will get as 3.3 ohms. That 3.3 ohms are in series with what? 1.3 ohms and 6 ohms. These all are in series. If you add 1.34, 3.3 ohms and 6 ohms, you will get 10.64 ohms as the input impedance, that DIN, across B and B dash. Okay. Find the input impedance of the network shown in figure. In this this is one port network. Okay, why you don't think that why star delta? Those are basics. Everywhere we need to know the basics. Those star and delta is used in the this module also. So star, delta, KVL, mesh. The first module is full basics. Using those things only we are going to solve with the second module. The one port network is what? It has only one port. So it is showing only one port. No, with the network. So in the same. So for those, you need to know star delta. If you have not known those star delta or some mesh analysis, KVL, KCL, please do watch my module 1 videos. They are available in the channel. Find the input impedance of the network shown in figure. How to find the input impedance? What we will write? Mesh equations will write for all the 4 meshes. That is KVL. You will get the delta Z. We'll find the value. See, applying KVL from mesh 1 to mesh 4, you will get these 3 equations. The fourth mesh, how it looks, if you see that, see carefully, I4 is in the opposite direction of what it is there. So what will write? I4 is equal to minus 0.5 IA. So 0.5 IA is equals to minus 0.5. IA is what? IA is present at this point. So IA is present at this point, it is moving in the 1 ohm. So 1 ohm, it means what? That is, the current is moving in the same direction. So plus I4, and here the current is moving in the opposite direction, I3. So minus I3. I'll make it clear once again. See, here IA is moving in this direction in the 1 ohm, as the current I4 is moving in this way, same direction. So you take as plus I4 minus 0.4 minus 0.5 into plus I4, and this, if you see, it is moving in the opposite direction for the IA, so it is minus I3. Okay, if you calculate this, you will get I4 as what? Minus 0.4 I4 plus 0.53, and minus 0.5 I3 plus 1.54 equals to 0 as fourth equation. After getting the fourth equation, what you will do? You will write the matrix. How to write matrix? Delta Z is equal to, using this 1, 2, 3, 4 equations, 1, 2, 3, 4 equations, you will write the matrix. After writing the matrix, as I told in the previous sum, you calculate the delta Z in this way, that is plus, minus, plus, minus, plus 10 into this, and minus of minus, that is plus 10 into the other values. So you will get the delta value from this. After getting the delta Z value, what we need? Delta 11. If you want delta 11, what we need to do? Cancel this first column and first row. Then you will get this as the delta 1. Delta 11, you get 159 ohm cube. Then after writing that, Zn is equals to what? Delta Z by delta 11. Delta Z is what? 590, and delta 11 is 159. You will get 3.711 ohm as the input impedance. For the one port network represented schematically in figure, choose the bottom node as the reference. Name the junction between 3, 10 and 20. Yes, S is Simon. Simon is nothing but, so the network is in the form of admittance. The resistance is given in the form of admittance. Keep that in mind and write the things. Then V2, conductance is V2, and the remaining node as V3. Write the three nodal equations, compute delta Y, calculate the input impedance. Okay, what they are telling is, consider this as V1. Why? Because it is V1. Consider this as V2 and V3 in the question. If you see, it is in the form of Simon value resistances. That is nothing but admittance. Admittance is what? Inverse of the impedance. So whenever the values are given in the form of admittances, you need to find the nodal equations, as I told in the theory of the one port network. So what we need to do? We need to apply KCL at node 1. What we get? 0 equals to 3 V1. Why? Because it is Simon. Now if it is 3, for example, if it is in the 3 ohm, what we do? We write 3 V1 by 3. In nodal, what if we apply KVL? One more small, sorry, not KVL, KCL. KCL at node 1 or nodal analysis at node 1. But here it is not 3 ohms. If it is 3 ohms, you need to write V1 by 3 is equals to 0. But here it is in the form of Simons, that is in the form of admittance. So it is inverse of what? Inverse of the impedance. So we will write 3 V1. Okay, 3 V1. 3 V1 plus 0 V2 plus 0 V. There is no V2 and V3 component. In the same way, KCL at node 2 will write, that is 3 into V2 minus V1 plus 20 V2 plus 10 into V2 minus V3. In the same way, we write for KCL at node 3. If you don't know nodal analysis, there is a separate video of nodal analysis in my YouTube channel. Please go check with that nodal analysis. You will get you'll understand. But whenever it is in Simon, it should be multiplied 3 V1. Whenever it is in the form of ohms, 3 ohms, like this. If it is then you will write a 0 is equals to V1 by 3. Keep that in mind. As they are in the admittances form, we just multiply. Why? Because admittance is inverse of impedance. Then delta Y we will write in the same way that we are writing in Simon. If you see here, yes, Simon, we need to write 3, 0, 0, minus 3, 33, minus 10, 0, minus 10 and 17. After writing this, what will get? We want Yn, right? They are asking for calculate input admittance. For Yn, what we want? Delta Y by delta 11. If you want delta 11, what? We remove first column and first row. Then we'll get the delta 11. That is minor of delta Y. After calculating this delta, that is 33 into 17 minus 10 into 10, that is minus of minus plus, no, to 10, this multiplication minus this multiplication. So you will get 461 Simon square. Here it is not ohm square, it is Simon square, and here Simon cube. Why? Because it is the admittance. So Yn is equals to what? 1383 by 461, that is 3 Simons as the admittance, input admittance. Next question, with reference to one port of figure which contains a dependent current source controlled by a resistor voltage, calculate delta Z and compute Zn as the value. how you will write? You will write the mesh equations. But if you see here, this is a one current source, that is dependent voltage dependent current source is a single, is only it is just one single present, like only one of the current source is present between two meshes. What we need to do? We need to eliminate that and write the equations. But we need to consider here Zn is written here, no? So we'll consider this as I1 and this as I2. The currents will not change. I1, I2 will be same, but we just remove this. I'll show you that. Even these kind of sums also have done in the mesh analysis. Please do watch in mesh analysis of the video. Anyway, I'll explain here once. Here I have removed this C. Why? Because it becomes a super mesh. Okay. So if you remove that, this I1, I2 will be not removing C. Why? Because those currents should not be disturbed. We are just removing to make it easy. Apply mesh analysis to the meshes. When if you apply here, it is plus minus, that is minus I1. Here plus minus 4 into, with respect to I2, no, I2 minus I3 equals to, you will get this equation. Then you will apply the mesh analysis to the next mesh. For this mesh, if you see here, it is plus minus 10 I3 plus minus 5 I3 plus minus 4 into, with respect to I3 we are writing in the mesh equation, so I3 minus I2. So you get as 0 is equal to minus 19 I3 plus 4 I2, and taking minus common, you will get as 0 is equal to 0 I1 minus 4 I2 plus 19 I3. From this you can easily write delta Z. And one more equation we require. If you see here, we have already removed this. We need to put that back. By putting that back, we need to find the value over there, that is 0 minus, if you see, the current is passing in this way, but the current what we are taking is in the opposite direction of here. So what we will do, it is minus 0.2 V1 we need to take, minus 0.2 V1, and if you see, this is in opposite direction, so we will take this is in the correct direction, in the same direction, then you will take plus I1. Then this is in the opposite direction of this, so you will take minus I2. Then I1 minus I2, if you rearrange them, what you will get? 0 is equals to I1 minus I2 plus 2I3. You write this in the form of, there is three equations in the form of delta Z. You will get as 10, 4, minus 4, 0, minus 4, 19. From that determinant, that is you get as 170 ohm cube. Then delta 11 is what? Remove first column and first row, so that you will get the minor of the delta Z, that is delta 11 minus 419 minus 12. You will get as multiply this and minus of this multiplication. Then what you will get as 11 ohm square. Then Zn is equal to delta Z by delta 11. Delta Z is 170 ohm cube by delta 11 is 11 ohm square. Then you will get Zn as 15.45 ohm as the input impedance. So these are the questions. I tried my level best. I've put the questions from the textbook based on the VTU syllabus itself, from VTU with syllabus. The textbook I am referring and the VTU has given in the syllabus is what is Hayat, Hayt, Hayat book, and one more book is Roy Chowdhury. These two books, first model is from Roy Chowdhury and second model is from Hayat. So from the textbook only I am taking the questions, because in the question paper also from the textbook preferred only they will be giving the questions. I am solving all the sums, exercises, everything of the textbook, so it will be useful for you. And these are the two questions I have given as a practice. Please do practice. If you practice only, when I am telling also, if you practice only, you will get to know how to write. So please do practice. Why? Because it is a problematic subject. It is not a theory. So practice it. If you have any doubts, please put in the comment box. If you want any other topics also, please tell me, so that I will plan and I will make a video of it. It is same. Write the 4 equations, mesh equations, write the delta Z and find the delta 11, then find Zn is equal to delta Z by delta 11. Here if you see the same question I have already found for the removing A and A port, B and B port, but I am given here for removing C and C port, that is C and C terminals, and find the Zn. So try this. If you have any doubt, please do comment in the comment box. Thank you. I'm stopping this video here. One port network is done. I'll do the next topics separately in the next videos. Thank you. From Sri Sai Tech Edu YouTube channel. Read, lead, success. Keep reading.